Let me start with a little context, and the issue of replacing old equipment that no longer meets environmental or safety standards is generally not a problem for most pieces of large capital equipment, because economics saves you. Old equipment gets more and more expensive to operate and maintain. It requires replacement, and new equipment becomes cheaper to operate. So at some point, usually well before the old equipment is worn out, it gets replaced on economic grounds. That's never going to be the case, never has been, and probably never will be the case with nuclear power, because nuclear power costs have only ever gone upwards. Operating costs tend to be quite a low proportion, and they're not reducing very much. So power plant life extension is going to be very attractive to owners of nuclear power plants. If that process of natural replacement doesn't happen, then regulation in other sectors tends to step in. And for example, after a serious accident in 2003, a decision was taken in 2005 to phase out single-skin oil tankers. Similarly, because of the perception that acid rain was much more damaging than we had previously assumed, the Large Combustion Plant Directive led to the replacement, to the forced closure of coal-fired power plants. Again, that hasn't really happened with the nuclear sector. The only relatively similar thing is the decision by the European Union to force the closure of some Soviet-designed plants in Eastern Europe. But even the majority of RBMKs, the type of plants that were concerned at Chernobyl, are still in operation. So there hasn't been that process for nuclear power. If we look at license duration, the United States is very much on its own in this, that it's the only country in the world that has fixed license durations of 40 years initially. And if you look at the NRC's, the Nuclear Regulatory Commission site, it says very clearly that this wasn't based on any perception of the expected physical life of nuclear power plants. It was based on economic and antitrust considerations. So it wasn't that they expected plants to last for 40 years. Other countries license plants from major maintenance shutdown to major maintenance shutdown. And there's an increasingly common practice to carry out periodic safety reviews. We've heard about those this morning. There is considerable variation between how those are carried out. We heard for France it's a legally required process. In Britain it seems to be rather an ad hoc process. So why historically have nuclear power plants been closed? For design life, and we have to remember that design life, particularly several decades ago, was very much a guess. We had no idea how long materials would actually last when they were subjected to long-term irradiation. But we seem to be a long way away from the position that we are, for example, with aircraft, which have a fixed number of flying hours for an airframe before the plane must be retired. There doesn't seem to be any suggestion that that's going to be imposed for nuclear power plants. Counting life simply tells you how long the banks want their money back over. Regulatory life can only apply in the United States because that's the only place where nuclear power plants can run out of their regulatory life, and it's never happened in the USA that a plant's been closed down because it reached its 40 years. Political life, some does occasionally lead to plant closures. There have been several countries that have adopted phase-out policies. Most have not done much about them. Only Germany and Italy have systematically closed down plants. Physical life, life-limiting components like the pressure vessel, no longer acceptable. that seems to be quite a rare occurrence and tends to be with the older designs of plants. Most plants that are retired on a combination of economic and technical issues. In other words, the cost of keeping the plant in operable condition with its operating costs, its maintenance costs, and any repairs that it requires exceeds the value of the plant, and the plant is simply shut down because it's not economically viable. That's by far the most common source. Where is life extension going to be important so far? Well, nuclear power capacity is very concentrated. 2/3 of the world's reactors are in just 7 countries. But if we look at the issue of aging, the issue is even more concentrated. And about half the old reactors, and for these purposes I've said reactors over 35 years old, half of them are in the United States. 12 are in Japan, and we can't learn much from Japan because it has other more pressing issues than life extension on its mind. And some are in Russia, and again, Russia is not an easy place to get information about regulatory processes. France has 38 reactors aged 30 to 37 years old, so the natural consequence of a crash program of construction is that you end up with a crash program of replacement. And I listened with interest the careful wording between ASN this morning and EDF. I think that the reality is that I'm in no position to doubt the word of the representative of ASN, if they decide not to allow plant life extension, then reactors will start going offline in France very rapidly, and by 2024, about half of the capacity will be lost. And given the failure of EPR technology, it will be at least about 2030 before any replacement nuclear capacity could come online, assuming that EDF has enough money to finance that replacement capacity, which it doesn't. So France and the USA are the countries to focus on, because they are the countries where necessarily they will have developed systematic policies. Other countries are operating on much more on a one-off ad hoc basis, not necessarily any the worse for that, but if we're looking for coherent policies, it's France and the United States that we need to look to. So far, 18 commercial reactors have been retired in the United States. 14 of those are for economic reasons, none because they reached the end of their license. And the retirement of plant for economic reasons tends to correlate with low gas prices. So around 1990, when the gas price in the United States was relatively low, then a number of nuclear power plants were retired. Now, because of shale gas, nuclear power plants are again becoming economic, and 5 retirements were announced in 2013. 3 because of the need for major repairs, and 2 simply on running costs. The operating costs alone were too high to justify their operation versus building a new gas-fired power plant. Mark Cooper, a very good researcher from Vermont Law School, is claiming that 37 more reactors are at risk of closure, 11 at serious risk. And of those, only 2 are not due to this combination of repair costs and high operating costs. The other 2, there are different reasons. So in the United States, operating cost is a very serious issue. The United States, as I said, has the oldest set of nuclear power plants in the world, and the oldest plant in the United States was commissioned in 1969, so it's now 45 years old. And planning for power plant life extension goes back to 1982, when the Nuclear Regulatory Commission first began to hold meetings and discuss how life could be extended. And by 1982 in the United States, building new nuclear power plants was near enough an impossibility, so new life lifetime extension was the only way forward for the nuclear industry. The first application was made in 1998 when the plant was only 23 years old, so 17 years before it ran out of time, they were applying for a life extension. And the NRC is now expecting to receive license extension applications to 80 years from about 2018 onwards. So they are racing ahead. So given that France is still deciding whether to go beyond 40, the United States is close to deciding whether to go up to 80. By 2012, most US nuclear reactors had been given life extension. Some were still awaiting a decision, and some of the newer ones were yet to apply. The process seemed to be very straightforward initially, and up to 2006, 50 applications were all completed within the 30-month target that the NRC had set itself. And provided you apply 5 years before you get to 40 years, then the plant does not fall offline at 40 years. It can wait until there is actually a decision. From 2006 onwards, the process seems to be taking much longer, and it's not clear how far that's because the process is becoming more rigorous, and how far it's because the type of plant that's going up for life extension is more problematic than the ones that were originally given life extension. At the moment, there is a moratorium on power plant life extension decisions since 2012 imposed by the NRC, and that's because of the awaiting a decision on high-level waste repository following the abandonment of the Yucca Mountain proposal. If you look for data on the cost of power plant life extension, it's extremely hard to get. There are very few of the utilities will give you any significant data on how much it has cost them to life extend the plants, but there's no evidence that any power plant life extension has led to significant plant modifications. You cannot find in the press or in the accounts of the companies any evidence that serious equipment changes, modifications, additions have taken place to allow power plant life extension. Moving on to France then, as was said earlier, there is a 10-year process, periodic safety review, and in contrast, the United States, where almost every reactor is a one-off. You have 4 different reactor vendors, each with different models. You have maybe 15 architect engineers designing the balance of plants. So the only commonality is between twin plants on the same site. By contrast, France has a very standardized set of reactors, so the process of power plant life extension should intuitively be simpler in France. I'm being careful not to say it's simple because it probably isn't. It also seems that the periodic safety reviews have been quite a serious process, and if you look back through the literature, you'll see that earlier PSRs have led to issues about seismic protection and a figure of 1.9 billion euros for modifications to take account of improved seismic protection. This is 10 years ago, where it was undertaken. Withstanding low ambient temperatures, and the design level that the plant should stand up to went down to something like minus 35 degrees from a much higher temperature. And pressure vessel integrity, again you heard about the Tricastan plant, which has a special regime which requires that it be looked at every 5 years. So PSR in France seems to be a serious process. The process of life extension in France seems to have been interrupted by the Fukushima events, understandably, and ASN has said that it was putting the life extension process on hold while it dealt with the issues that were thrown up by the Fukushima disaster. And it appears that France has been significantly more rigorous than other European countries in its stress test requirements. For example, EDF estimates 10 billion euros for Fukushima requirements, and that works out at about 160 million euros per megawatt. EDF has said it is operating to the same standards in the United Kingdom as in France, yet the bill for Fukushima upgrades in Britain is about a fifth of that for France. And I would be very reluctant to accept the explanation that British nuclear power plants are so much better built and so much safer than French nuclear power plants. So there is some explanation to do there, and it's a shame that the British regulator's not here to do that. This is the legendary graph that is going around the system with bits that appear and disappear according to how you cut and paste it. I won't talk about it. Let me finish up then by asking the final questions. What standard should we be looking to upgrade to? Is it defensible to essentially give a whole new lease of life to a nuclear power plant of 20 years to a design that wouldn't stand a hope of being licensed if it was a new build being built today? I mean, is it premature to give life extensions 15, 17, 18 years before the existing license expires? I mean, in Britain, my car has to be tested every year, and it happens to be in June. I can't take it to the garage in July and say, okay, give me an extension for the next 23 months. I need to wait till the end of time. It seems a bit premature, the US procedure. Finally, an interesting quote from the president of ASN. ASN's requirements are very different from how the US nuclear regulator evaluates life extensions, because in the US, life extensions are based on the initial safety standards from when the reactor was built. Now, instinctively, that sounds sensible. Of course, you would want reactors to be judged against current standards, not old, out-of-date standards 40 or 50 years ago. And I put that to a former commissioner at the Nuclear Regulatory Commission, and his response, and he wasn't in any way trying to defend the NRC, was that evaluation is not the same as enforcement. You can evaluate against current standards, but you might allow the plant to still continue to operate. So it's an interesting contrast, and I think it's one that deserves a little bit more discussion here. Thank you.